In this topology, I'm going to configure R5, 6, 7, 8, 9, and I'm going to put them in area 1. Of course, R5 is ABR, R6 is ABR. Then I'm going to examine having two different ABRs and how we are going to reach the different parts of the network. So the configuration starts at router 5. What I'm going to do is to check the current configuration. You can see that I have put all of the interfaces in area 0, but this is going to change. So what I'm going to do is to go to router OSPF 1. I'm going to say no network like this, but I'm going to be a little more specific about this. So if I say do show IP interface brief, this is going to tell me that I have this network, which is going to be between 1 and 5, and I'm going to say /24 in area 0. I have 25 here under this, but we are going to have something like 57. It's going to be in area 1. So I have not configured 57 for now, but I'm going to do that. So let's say that 57 is going to be in area 1, and also that's it. And I'm going to also say that 5555/32, that's going to be in area 0, the loopback interface. So I'm going to commit this configuration, and I'm going to say save it. The same configuration goes on router 6. So if I just say do show run, I'm going to begin from router. This says that the same configuration needs to change. Router OSPF 1, I'm going to say no this, but as a matter of fact, I'm going to have network 10.10.16.6. As a matter of fact, 16.0 is going to be okay. /24 on area 0. And 26.6 is going to be in area 0. And also network 6666/32 is going to be in area 0. But the other network is going to be 69, so I'm going to put it in area 1. So that's going to be 69, which I have not configured yet under this. I'm going to say interface ETH1 is going to have an IP address of 10.10.69.6/24. And then I'm going to commit this. And also I'm going to save this. Okay, now that I have done this, I need to go back to router 7 and configure this 57 as well. So that's going to be interface Ethernet 1 as well. Interface ETH1 IP address is going to be this /24. And I'm going to say commit and do WR. Okay, now I'm going to go back to router 7. Router 7 has two interfaces and a loopback interface, which I'm going to configure in a second. I'm going to put those interfaces in area 1. So let's go to router 7. Interface ETH1 is going to have an IP address of 10.10.57.7. ETH2, not ETH3 as a matter of fact, is going to have 78. So that should be 78. And interface loopback is going to have an IP address of 7777/32 secondary. Now it is time to configure OSPF here. OSPF is going to have a router ID of 7777, and the network 7777/32 is going to be under area 1. And I would say, instead of that, I could just go with all the interfaces. So why would I do this? So let's change this like this. /0 under area 1. That is much better configuration. And so I'm going to commit this and save the configuration as a matter of fact. So as soon as I do this, I'm going to check IP OSPF neighbor. And after some time, I should see that I am in full neighborship with router 5, which is okay. Let's do the same thing on router 8. So I'm going to have interface ETH3. IP address is going to be 10.10.78.8/24. ETH2 is going to be 89. And also interface loopback is going to have an IP address of 8888/32. So I can just go to router OSPF1 and I'm going to say network is 0000/0 under area 1. And also I can just configure router ID manually. So I'm going to say commit, and there's a problem here. What is the problem? So I have just put these under area 1. The interface, oh okay, the interface loopback has a problem. So I should say no this, but this. So now I can commit. So do WR and save the configuration as well. The final one is router 9, which is going to be an ABR for itself. And later I'm going to show you some interesting thing about this contiguous or disjointed areas, which router 4, area 4 is this kind of an area because it doesn't have direct connection to area 0. We are going to fix it in the next video. But for now, on router 9, let's do the configuration. I'm going to say interface ETH1. IP address is going to be 10.10.69.9, and interface ETH2 is going to have say 89. And interface loopback, of course, is going to have 9999/32. That's it. And router OSPF 1 is going to have a router ID of 9999 and a network of 9999/32 is going to be under area 1, and also a network of 10.10.89.0/24 is going to be under area 1 and also 69. So commit the configuration, and also Ethernet 3 should be under area 4. So I'm going to say this is area 4, and that would be 109. So 109, I didn't configure it, but the interface is ETH3, and IP address is going to be 10.10.109.9/24. So I'm going to commit and do WR. Okay, let's see what the database is like right now. If I say do show IP OSPF database, so you can see that we have these routers here, the advertising router. This is LSA type 1. I have not changed the interface's network type, so you can see that there is LSA type 2 as well here. We can just omit this by changing the interface types to point-to-point, which I didn't, of course, do that. And then we get to here, which is the summary link state. And you can see that we have two different advertising router, which is going to be router 5 and router 6. And I have kind of equal distance multipathing or ECMP configured in here, because I can just get to different parts of other networks from two different paths. Now the important thing is, if I just check the IP routing table, you can see that although I have multi-pathing enabled, but inside my routing table, I only have one path, and you can see the distance here. Now that is because right now router 9 is closer to this ABR. So if I just go with one of these routes, and if I just say do show IP route this one, this is going to tell me that the closest one is going to be 69.6, which is going to be router 6 down here. And because the metric is 131,071. And of course, this is the best, and this is installed in my routing table. Now, what I'm going to do is to go to router 8 and check the same thing. I'm going to just check this route here. So if I just go to router 8 and check this one, it says that now I have two different paths to get to the destination. And of course the best one is going to be both of them. You can see that I have both of them installed in my routing table. This one goes through router 9, which is going to be the downside, and then going to here. It has 2 hops to the destination. The other one goes through router 5, which is this one, 1 and 2 hops up there. So both of them are equidistant, so I'm going to have both of them in my routing table. So if I just say show routing table, show IP route, you can see that for almost every prefix that we can see here, there are 2 different paths to the destination via both of these interfaces, one through Ethernet 2, one through Ethernet 3, and you can see almost every inter-area route has 2 ways to get to the destination. The same thing should happen to router 7 as we saw on router 9, because router 7 is closer to router 5. So if I just go to router 7 and say do show IP route, you can see that I only have one way to get to the destination, and that is through router 5, because router 5 is closer to us. So when you have 2 ABRs, the best way to get to inter-area routes is going to be the one which takes you to the closest ABR, and it just checks everything, and the distance is going to be added to that. Now I'm going to check the distance as well, as a matter of fact, not distance, the metric to the destination. So I'm going to say do show IP route 1111/32. It says that the distance is 131,000 something, and this is on router 7. I'm going to check this on router 5. So if I just go to router 5 and examine the same command on that, which is my ABR as a matter of fact, it says that the metric is 65,536. This means that the metric to get to the destination is this one, and router 7 has added the metric to get to router 5 plus the metric that is advertised by router 5, and then it has come to this value that you can see here. So if I just say do show IP route, and that is 1010, not 1010, let's say 5555, you can see that I have an extra P here. Okay, you can see that this is 65,000 to get to router 5, and from router 5, of course, to the destination is 65,000. Now, if you just add these two, that's going to give you 130,000 something, and that is exactly what you see for here as the metric to get to the destination. So metrics are additive. The metric which is reported to you from router 5 is this. Now, something interesting is going to happen here. Let's say that I am checking the route on router 5. Let's say that I'm going to say do show IP route, just every route that is here. One of the routes that are E2, or let's say that is external route. You can see that for E2 we have just the, let's say this one, 16, 16, 16, 16. So you can see that it says that the metric is 1. And that is interesting, because everything which is advertised to you when it is E2 type, that's going to have a metric of a default metric which is going to be advertised to you, and in this case, for example, the metric is 1. Now the same route on router 7, if I just go to router 7 and check this 16, 16, 16, 16, again the same thing is happening here. You can see that the distance is the same as what you see everywhere in your network, and that is because this is type E2. Now what I'm going to do is to go to the redistributing router, which is router 15 in my case. On the right side, you can see that this is a router that has redistributed BGP into OSPF, but I'm going to change the metric type there. So if I just go to router 15 and I'm going to log in, I'm going to just show you the running config of that section, but begin from router. You can see that I have redistributed here it is, redistributed BGP. So I'm going to go back to this part. So let's go to configuration mode and go to here. And now I can just change the metric type. Metric type is by default 2. But if I just change it to 1, let's see what is going to happen. I'm going to say commit, and also I'm going to advertise something here into my OSPF network. I'm going to advertise this 15, 15, 15, 15 as well. So I'm going to say network this /32. That's going to be in area 3, I guess. Yes. So I'm committing this. Okay, so let's go back to router 7 and router 5 and see what is the difference between the metric that we have seen before with the metric that is currently being advertised. So if I go to router 5, this is the previous result. And now if I just go with this, you can see that 16, 16, 16, 16. Now instead of 1 has an actual metric configured for that, which is 327,000 here. So I expect to see a little more on router 7. So if I just go to router 7, currently this is only 1, but if I just go with show IP routing table and go down, you can see that this is 390, because this is 60,000 to get to router 5, and from there 330,000 to get to router 15. So in case you go with E1, which is metric type 1, and you can see that this has changed to E1 as a matter of fact, and the same thing on all external routes on router 5 as a matter of fact. This is, you can see that has changed to E1, and also the summary that we have advertised is E1 now. Instead of 1, you can see a value for that. So changing the metric is going to be like this, and in case you really want to have your actual metric to get to the destination, then you should go with E1. But if metric is not so important for you and just the way out of your network is important, then E2 is going to be okay for your network. Now in next video, what I'm going to do is to configure route area 4, and we are going to check how we can solve the problem for discontiguous or disjointed areas.